Our heading is electropotential. So what is electropotential? It is basically the ability to lose electron or gain electron. So basically some metals have tendency to lose electron and some of the elements have tendency to gain electron. So to calculate that tendency, we have some concept that is electropotential. It is basically the measurement of voltage. So the measurement of voltage gives an idea about the element, whether it has tendency to gain electron or lose electron. So if an element have tendency to lose electron, so in that case we are going to calculate electropotential in terms of oxidation potential. If an element have tendency to gain electron, so in that case we are going to find out its reduction potential. So we can say that we have two types of potential. First is oxidation potential, second is reduction potential. Oxidation potential is the ability of an element to lose electron, and reduction potential is to gain electron. So to understand this, one more thing, some element have both the tendency, like copper, which can gain electron, sometimes it can lose electron. It basically depends with what type of electrode it is in connected. If other electrode which is connected with copper have tendency to gain electron, then this copper will lose electron. So it is all about the comparison between the two electrodes. So if I'm taking example of copper, I'm assuming this is a copper sulfate solution in which I have copper electrode, this is copper electrode, and this is copper sulfate solution. So what are the possibility of reactions which can occur with this electrode? This I'm already connected it with the other half side. So the possibility is here the copper 2 plus ion is present and sulfate ion is also present. So there are three possibility. First is copper 2 plus ion strikes CU rod. Second possibility is copper 2 plus ion strikes CU rod and bounce back. Basically, in first case, copper 2 plus ion is striking to copper rod and it gains 2 electron. So I can write it as copper 2 plus 2 electron will give us copper solid. Here in second case, there is no change. Now there is also third possibility, which is copper solid loses electron to form copper 2 plus ion. Means copper will change to copper 2 plus and give 2 electron. So we have three possibility which will be happening with the copper electrode or with the copper 2 plus ion. So among all the three which will occur, it is decided by the element, whether it wants to lose electron or it wants to gain electron. So that's why we have a concept of two type of processes, that is oxidation and reduction. So if that element have tendency to gain electron, then we are going to calculate reduction potential. So moving to next part, that is the conclusion. Conclusion is that if copper solid goes to copper 2 plus 2 electron, then here we will have oxidation potential, oxidation electrode potential. Second possibility, if copper 2 plus gains 2 electron, it goes to copper solid. In this case, this is reduction electrode potential. So there's the confusion now, because in both the cases we are using copper electrode and copper sulfate solution. So which one is to be taken, which one is to be considered? So for that we have concluded that instead of using oxidation and reduction electrode potential, we use only reduction potential value, reduction electrode potential as a basic sign convention, and our reaction will be written in reduction form. Now moving back to first equation, giving it first and second. So in first case, because we are calculating potential value, so we will have some E naught value. Basically, where we are calculating EMF voltage, so we have E naught value. Now what is E naught? E naught or E is basically EMF, or we can say that it is voltage or electrode potential at standard condition. And what is that standard condition? Standard condition is 1 atm pressure and 298 Kelvin, and we usually call it as STP condition, standard temperature and pressure. So it is basically the potential, the voltage value which we will be getting in the voltmeter, and this is represented by E naught, and it is electrode potential. So in first case, when copper is losing 2 electrons, it will have some E naught value. So here, if it is doing oxidation, then we can write it as copper then slash, which shows it is changing to copper 2 plus, and sometime we can also write it as copper changes to copper 2 plus. So this is cell representation. This is half cell representation, oxidation half cell representation. In second case, and here also we will have some E naught value in first case. And in second case, we can write this reduction reaction like here here we have copper 2 plus, it changes to copper solid, or copper 2 plus changes to copper. So this is basically the cell representation. So we can adopt both, and in second case also we will have some E naught value. So just because of the confusion which one has to be taken, we have concluded by latest sign convention, that is we will be using reduction, we will be using value of reduction electropotential only, and this reduction potential is and will be called as simple electrode potential. We will simply name it as electrode potential, and it will be understood that we are using electrode potential, which is basically reduction electropotential, and the reaction will not going to be in oxidation format, it will be represented in terms of reduction format. So if I have copper electrode, then for copper electrode it can lose electron or sometimes it gains electron. So instead of writing the reduction format or oxidation format, we simply use a simply use the reduction format because it is in latest convention. So copper 2 plus will gain 2 electron and will change to copper, and we will have some E naught value, and it is 0.34 volt. So we will write E naught as copper 2 plus changes to copper, because we have understood that it will have to be written in reduction format. That's why I'm writing copper 2 plus changes to copper, and its E naught value is 0.3 volt. So this is our concept. Instead of using oxidation potential, we are using reduction format. We are writing reaction in reduction format, irrespective of the electrode which it wants to oxidize or reduce. We always write the reaction in reduction format, and its E naught value is in respect of its reduction value. So now if I want to find its oxidation electrode potential, so you will have to always remember that oxidation electrode potential is always negative of reduction electrode potential. So it is understood, because we are just reversing the reaction, but we are not going to use oxidation electrode potential anywhere. But you have to remember this, that it is the negative value of reduction electrode potential, because we have just reversed the reaction. So thank you so much. It is all about electrode potential, which we have divided into two parts, that is oxidation electrode potential, and second is reduction electrode potential. So we cannot use both sign convention. So instead of using oxidation potential, we just use reduction potential for calculating standard electrode potential or just electrode potential. So thank you so much.